2.3 is the mole and gas conversions as a part of Foundations in Chemistry Part 2. And we are looking at the outcome FC2, constructing an understanding of a mole as a unit for measuring the amount of a substance. We will learn how to perform molar calculations, including gas calculations. Avogadro's law says that the same volume of gas contains the same number of particles. It does not matter what gas you have, they all contain the same number of particles provided that they are at the same temperature and pressure. This leads to an even more useful fact that at room temperature, or 25 degrees Celsius, and 1 atmosphere pressure, or 101 kilopascals, 1 mole of any gas occupies a volume of 22.4 liters. We now have 3 interpretations for the mole. 1 mole is 6.02 times 10 to the 23 particles, and remembering that particles is, we can use atom when we have a lone element. We use the word molecules when we have a covalent compound. And we use the word formula units if we have an ionic compound. We have 1 mole is equal to molar mass, or we've often seen it as, some compounds measurement is when we look it up on the periodic table, we add all their masses up, it's in grams per mole, or 1 mole is equal to our molar mass, and 1 mole is equal to 22.4 liters at STP for a gas. This gives us 3 unit factors to convert between moles, particles, mass, and volume. And when converting moles to volume or volume to moles, we use the following conversion factors. 1 mole over 22.4 liters at STP for a gas, or 22.4 liters at STP for a gas over 1 mole. Now, the really important thing that we need to keep in mind is that this is talking about liters of a gas at STP. Later down the road, we learn about liters as in like liters of water or liters of a liquid. This conversion only applies to liters of a gas. So it has to say liters of a gas at STP. Liters at STP in the question is when you can use this conversion factor. If it doesn't say liters at STP, then you are more than likely working with a liquid, which it does not use this conversion. So in this example, it says a sample of methane, or CH4, occupies 4.50 liters at STP. So that's saying, okay, we need to use a gas conversion. And it asks how many moles of methane are present. So we use molar volume of a gas, or 1 mole is equal to 22.4 liters. We always start with our number in the question, or our question starts with 4.50 liters at STP, and we know our gas conversion is 22.4 liters over 1 mole, or 1 mole over 22.4 liters. We have liters on top, so we need to put 22.4 liters on the bottom, which means we have 1 mole on the top. Our liters cancel out, therefore we are left with the units mole on top, which is what we want, and then we can go 4.50 times 1 divided by 22.4 to get our answer of 0.201 to 3 significant figures from our question. 0.201 moles of our methane. For this next example, what is the mass of 3.36 liters of ozone gas, or O3 at STP? Oh, we want mass. Remember, whenever we see mass or grams in the question, we need to do a molar mass calculation. And we have O3 this time for ozone. We know to find molar mass, we need to go, okay, if we have oxygen, there's 3 oxygens, 3 times 16. We go 3 times 16 on our calculators, we get 48 grams per mole. We found that molar mass, now we start with our number in our question. So 3.36 liters. And it's saying it's a gas at STP, so we can use that conversion of 22.4 liters over a mole. And now we have moles on top. We want to get to mass. So from the previous section of notes, we can use our molar mass to convert to grams. And since we have moles on top, we need to make sure we have moles on the bottom, which means 48 grams goes on the top. And we double check our moles cancel off. And we can multiply everything on the top. 0.36 times 1 times 48 divided by 22.4. We get 7.2. And we need 3 significant figures, so 7.20 grams of O3. And we can use molar mass to calculate the molar mass of an unknown gas. Our question says 1.96 grams of an unknown gas occupies 1 liter at STP. What is the molar mass? So it says we have grams per mole, or we want grams per mole, we have grams per liter, because our question says we have 1.96 grams in 1.00 liters. So we have grams per liter, we want grams per mole. And if we look, we have grams on the top, liters on the bottom. We already have grams on the top, so we're good. Now we need to figure out a way to convert to moles on the bottom. Well, if we have liters on the bottom and we want moles on the bottom, we know we can use our gas conversion of 22.4 liters. Oh, we go 22.4 liters on the top to get those liters to cancel off over 1 mole. And if we look, we end up with grams on the top and moles on the bottom, which is what we want. We have 1.96 times 22.4 divided by 1. We get 43.9 grams per mole as our final answer. Another example here, how many molecules of hydrogen gas, or H2, occupies 0.500 liters at an STP. Again, STP, that means our gas conversion. We want molecules of hydrogen, and we have 0.500 liters of hydrogen. We know whenever we see that term molecules, we're going to also need to use 6.02 times 10 to the 23. We have to use our Avogadro's number. But we start with our number in the question, 0.500 liters. And it says we have a gas conversion that we can use. We know we should use that one first because we're starting with liters. We'll need to use our gas conversion. Put 22.4 liters on the bottom per mole. The liters cancels out. And then our question's asking for molecules. We have moles on the top. We want to end up with molecules. We need to get that moles to cancel off by putting moles on the bottom and Avogadro's number, or 6.02 times 10 to the 23 molecules on the top. Our moles cancel off, and we're left with just molecules. And we would go 0.5 times 6.02 times 10 to the 23. And we divide that by 22.4 liters, which gives us 1.34 times 10 to the 22. Molecules. There we go. There's how we do gas conversions.